Now we're ready to begin talking about the next thing after evaluating expressions, which is simplifying algebraic expressions. Now there's a lot of writing here, so if you need to pause the video to kind of get things jotted down, always feel free to do that. That's the nice thing about a video. So what does it mean to simplify? Well, to simplify means to write in an equivalent simplified form or simpler form, if you prefer. So we need to write something in an equivalent form, but we want to make it simpler. So this is what we do with arithmetic. When we say 4 plus 8 equals 12, 12 is a simpler answer than 4 plus 8 was. So everything we've been doing with our order of operations, that's been simplifying a numerical problem. Now we're ready to talk about simplifying algebraic expressions. So consider the following question here. Here I have the expression 2x plus 5. My question is that the same as writing it down as 7x? In other words, when I have 2x plus 5, a variable, along with the number, can I just add the 2 and the 5? Well, to see if we can, let's consider a numerical value. And so what if we decide to make x be 3? If 2x plus 5 and 7x are the same, then when I plug x equals 3 in, I should get the same answer. In fact, I plug any number in, I should get the same answer. So I plug in 3 into 2x plus 5, so I evaluate it. I get 2 times 3 is 6, plus 5 is 11. On the other hand, when I plug in 3 for 7x, I get 7 times 3 is equal to 21. So they're not the same. They're not the same. In fact, we can't simplify 2x plus 5 any further. Cannot be simplified any further. And the main reason here is because that 2x, 2 and the x are being multiplied. Now remember, order of operations, we'd have to work that out to get an answer before we can add the 5. And so since we don't know what x is, we don't know its numerical value, we can't simplify that, and so we can't add the 5. So again, very important first thing here. If you have this expression like a variable term and a number term, we can't put those together, ever. Now, a key to being able to simplify some algebraic expression is a result that I've mentioned before, and that is our distributive property. Distributive property, recall, says that if you're taking a multiplication alongside an addition or subtraction, we can distribute the multiplication through. So let's consider an example here. Here I have 5x plus 8x. Now I don't know what x is. So if I was to follow strictly order of operations, I'd have to multiply the 5 and the x, get an answer, multiply the 8 and the x, and get an answer. And then I'd kind of be like stuck because I don't know what x is. But we can use our distributive property in reverse. You see, we have an a showing up here in each of those, so we're able to actually pull it out. And so we're able to do the same thing here. We don't know what x is, but it's the same in both of those. And so we can pull that x out. And then that leaves us on the inside with an arithmetic problem, 5 plus 8. Now 5 plus 8 is 13, and so the answer is 13x. So because of the distributive property, we're able to simplify. Now usually in practice, what we usually do is go straight from there over to the 13 without writing the middle step out. But the middle step is the key to understanding what's going on. Usually we don't write it out, but it is still the key to understanding what's going on. Okay, in the next video we're going to look a little bit more at some examples with simplifying and where we can or cannot simplify.